Over the last 52 weeks, I've enjoyed sharing with you my fascination with biology. If you've been through it with us, you've got yourself an understanding of how life functions, from the chemistry that makes cells work, ecosystem that make and it's never too late to catch up on those biology and eco on YouTube forever. But it's time to move on to something new, something bigger, because it's smaller, more beautiful, because it's invisible, more powerful, because it's everything. Crash course chemistry. My undergraduate degree is actually in chemistry, and I've been a lifelong lover of the subject, not just the rules and laws and the bonds and the coefficients, but of the men and women who shape the science that depend our understanding so magnificently. The Siberian misanthrope would revolution our understanding, the German war criminal who saved 1 billion lives, the French aristocrat who created the science of chemistry, and all he got for his trouble was beheaded. And of course, all of these stories is with the greatest science ever. What is matter made of? How and when do atoms come together? And what is an electron? What is silver? The chemical symbol Ag? How do we fix global warming? The answer to all of these questions, except for the last two, will be discussed. But those last two, if and when they get solved, I guarantee you will be solved of chemistry, and we'll be doing it in this beautiful new Jenkins. And our graphic stream will be Troll Cafe, which is what purple with slaving away on Crash Course Chemistry, your subscription box within the next. Until then, feel free to check out any of the biology that you make. We'll see you soon. Hello, I'm Hạnh and I want to teach you chemistry, but please do not run away screaming if you give me 5 minutes to try to convince you that chemistry is not torture, but instead the amazing and beautiful science of stuff. And if you give it a chance, it will not only blow your mind, but also give you a deeper understanding. This is just my opinion, but I think that understanding the world leads the world better than chemistry. Chemistry holds the secrets to how life first formed, how cancers are cured, how iPhones have bigger hard drives than, and how life on this planet might just be able to continue thriving even hours if. Chemistry is the science of how 3 tiny particles, the proton, came together in trillions of combinations to form, get this, everything. How chemistry is a particular, sometimes talked about as a bridge between the ultra and the more visible sciences, but calling chemistry a bridge is like calling eraser. Chemistry has it all. Math scientists, world-changing revelations, the product medicine, bombs, food, beauty, destruction, life and death, answers to questions you. I love chemistry, and I hope you can give you a glimpse into why. So today let's start out with maybe the biggest idea of all time and move on from better. Stuff is made from atoms. I know you aren't shocked, you aren't awed, you might not even be paying attention anymore, but when atomic theory was first proposed, it sounded, and yes, we call it atomic theory using the scientific, which is a well-tested set of ideas that explains many, not the colloquial, and luckily there's no one running around. But it wasn't that long ago that people, you wanna know who settled it for good? Einstein. Atoms had been postulated, but it wasn't until Einstein mathematically proved the existence of atoms that the matter was truly. And you thought Einstein was all about relativity and E equal mc squared. In 1827, a botanist named Robert Brown, and he noticed that they triggered randomly even when there was no movement. It was a mystery for a long time until 1905 when Einstein theorized that these as yet unproven atomic particles actually smacking into. He wrote up some fancy math showing that his theory predicted, and everyone had to concede that yes, tiny discrete bits of matter were indeed endless molecules and by extension atoms. Today we remember this botanist and his discovery. It's kinda crazy that every physical thing you've ever interacted with, it started with people wondering what could happen eventually, and of course it turns out that and you end up with one pure, unbreakable. The word atom indeed is from the Greek do. Of course, as we learned in World War II, so all the stuff that we think of as stuff is made of atoms, tiny discrete, depending on the arrangement of three simple. There's the proton, heavy and positively charged, the neutron about the same size, and the electron, which has the same amount of, and very nearly has no mass at all. About 1800 times protons and neutrons hang out in the nucleus, and thus are the nucleus. Electrons hang out around the nucleus and are the parts of. But before we get to the chemistry of the electrons, we first have, this is pretty important. The number of protons in an atom determines what element. 79 protons always gold, 59 protons always ratio medium. The number of it sits right on top of the box in the periodic. So an atom of silver with 47 protons in it. Depending on what is electrons, it might be part of a chemical that's silver color or black or blue or shiny or poisonous. But whatever it is, that atom is still silver and will remain an atom of silver because that core number is very, very difficult. Now you might have noticed its chemical symbol, the one or two letter so-called that tells you not Si, which is silicon, or Sv, which is perfectly available, but Ag. Why? To torture you? No. Silver, of course, because we've known about it for a long time, was one of, and back then it was called argentum, Latin for shiny, also the root of the word argent, where Spanish explorers heard rumors of mountains made of silver. The name Argentina, just like the chemical symbol Ag, despite neither of them being particularly representative. Nuclei, which is the plural of nucleus, they are thousands of times smaller than, and they mostly just sit around being exactly the same as, created billions of years ago, held together by the strongest of the four fundamental forces. The fact that nuclei are so boring is the very reason that while electrons can jump from atom, the number of protons is almost always extremely, so that core of the atom, the nucleus, always comes is the bit that we can bump, but always remains pure and behaves the same way as any other. The atomic number is the soul of the atom. Neutrons are important too, of course, in their own way, but they don't. One of the two keys to all things chemical is change. A charge, and since neutrons don't have any charge, they mostly, but they are nonetheless. We all know that like charges repel each other. Neutrons, you can pack silver's 47 protons together. They couldn't handle it, and so nuclei only clump together permanently when the right number. Silver needs about 60 neutrons to space out the 47. In fact, silver nuclei is also very 61, though that doesn't work, and the reasons for that I don't know. The atomic number of silver doesn't change. because the number of protons, but the relative atomic mass does. The relative atomic mass which used is basically the number of protons plus the number of neutrons, because silver has two different stable isotopes. Its relative atomic mass, about 52% of silver, has 60 neutrons. About the relative atomic mass then ends up being about halfway between 107 and 109. You know that I said these two, they have different masses but the same and are the same element, and so belong in the same place. In fact, the word isotope means the same place, and different isotopes have different mass. The mass number is just the total number of nucleons in the nucleus, a simple addition for a single atom rather than an average of all the relative atomic masses. So silver has two stable isotopes, one with a mass number of 107 and one with a mass number. There's an easy way to write the chemical symbol with the atomic number, the mass number or number of protons, and the charge out here, which tells you by simple addition. Or finally, because we conclude this first episode and thus our discussion of the atomic nucleus, a note on the pronunciation, and you are welcome to say nucleus, but if you can find it in you, it's probably best to switch over to nucleus. And that is all for today's episode of Crash Course, more about atoms than anyone did in like that. They were finally confirmed when Einstein the elements that are chemically, and the type of element an atom is defined by how many protons it has, that neutrons stabilize nuclei, that different isotopes of the same element are the reason relative, and you know that nuclei are uninteresting, and the electrons are where all the Crash Course chemistry film edited and directed. Dr. Heiko Langner is our chemistry consultant, sound designers, and our graphics team is. If you have any questions, comments, then in the thank you for watching Crash Course Chemistry.